or constraints in medical setting. So this approach is particularly valuable in resource-limited environments, such as ours, where we find ourselves in Nigeria. They will tell you there is paucity of fund, they cannot buy this, they cannot buy that. So we cannot be limited all the time as a result of this paucity of fund or lack of resources. So we need to do something in order to make the equipment available. So biomedical engineer, we leverage on locally available resources and as well as innovative thinking to develop an effective solution that ensure continuity and quality of healthcare delivery. Why is improvisation important? Importance of improvisation. Number one, resource optimization. So improvisation allows for the utilization of available materials to create function alternative. Available material that is available within our local settings, we can make use of it in order to create a solution to ensure medical services are not hindered as a result of lack of availability or shortage of medical equipment. Another importance is cost effectiveness. So you will agree with me that developing an improvised solution will definitely reduce costs when you compare with purchasing and maintenance of expensive one. The last one here is customization. You can customize a particular tools or equipment to tailor or in order to meet a specific need of the medical procedure or patient. At times, we improvise this wheelchair, a motorized wheelchair, electronically enabled wheelchair for the disabled people, so that that one is actually tailored to the particular need of such a patient. What are the skills that are required in improvisation? Number one, we have imitative improvisation. When you imitate somebody, that means you are copying somebody. You observe such an individual, then you now copy him in order to adapt whatever is doing to your own area of interest as well. So a person will observe what more experienced people are doing and copy their responses with minimal variation. This is an effective starting point for people with limited experience. For people that are not experienced, you can easily copy what somebody else is doing. Please, let's mute ourselves. We don't have much time. Let's mute ourselves so that we can run through the slide, then have our revision. So the second one is reactive improvisation. This is using input from environment and other people to develop your own reaction to an unexpected situation. That means you are not expecting such a situation to happen, but it has not happened. You now react to it. So without relying on others' action. This is generally developed after you have already mastered imitative improvisation. For someone to react to something, then you must have had experience from the imitative improvisation before you can now react. Then the last one is generative improvisation. It is about proactiveness, that is trying new things in order or when you are anticipating that such and such things can happen, rather than for you waiting that it happen, then you now react. So generative improvisation, it is about proactively trying new things to anticipate or catalyze what could eventually happen. So what are the guidelines for effective improvisation? Number one, you need to understand the core principle. For somebody to work on a particular machine, let's even take, for instance, our mechanic now. If they don't understand how a car works, definitely they will not be able to work appropriately on that car. So you need to understand the core principle of whatever you want to improvise. Then safety consideration. Safety is very key when it comes to medical equipment. So all improvised equipment must be tested rigorously to meet safety standard and not to compromise patient health. Collaboration is another guideline, which involves engaging medical practitioners, technicians, and other stakeholders. They can provide valuable insight into the practical requirements and constraints, leading to more effective improvisation. You want to improvise, you need to ask questions. Those people that are using that equipment, those people that will take care patient on such a equipment, the technicians that are working on that equipment, and other, even patients, they are also part of the stakeholder. You ask questions, you collaborate. So as a result of whatever you might have gathered, you can now use it to improvise. Then the last one is documentation. Keeping detailed record of improvised solution aid in replicability and continuous improvement. If you want to do such a thing another time, if you don't have adequate documentation, you can start from the beginning. But if you have documentation, you can just look at the document, then it will help you, it will go a long way in helping you to continue with another equipment that is different from the one that you have actually worked on. So there are challenges when it comes to improvised equipment. What are the challenges that we face in improvisation? Number one is regulatory compliance. So ensuring that improvised device or devices meet medical regulation and standard can be challenging, but it is necessary to guarantee patient safety. Number two is durability and reliability. So improvised solution at times may not always match the durability and the reliability of commercially produced equipment, which necessitate frequent check and maintenance. That means you need to be checking the equipment, then you need to carry out preventive maintenance as at when due. The next aspect of this lecture is glass blowing. What is glass blowing? It is a technique that is used to shape glass by heating it until it becomes soft, and then you inflate it or manipulate it into the actual shape that you desire. So this method is commonly used in biomedical engineering workshop to create and repair laboratory equipment such as pipettes, flasks, burettes, and condenser. So glass blowing is dated back to the 1st century BC. All those one, their story, we can look at that one later. What is the importance of glass blowing in biomedical application? Number one, we use it to produce high precision glass instruments for experiment purposes or for research purposes. It allows customization of laboratory glassware to a specific research need. If there's a research need of a glassware, then you can now produce such a glass using glass blowing to make that specific. You can even be customized. You can write name of the research that you want to carry out so that people will not just carry or take the glass away. Once they see, they know this is meant for a particular research work. So it also enable repairs and modification of existing equipment, thereby reducing the cost of purchasing a new one. What are the type of glass that are used in biomedical engineering for glass blowing? We have different type of glass that are used in laboratory setting based on their property. Number one is borosilicate glass, e.g. Pyrex. It has the property of high resistance to heat and chemical. That means you can subject it to heat without the glass losing its chemical composition. And it can also withstand the chemical without failing. So it is used for beaker, test tube, and flask. Then we have quartz glass, which has excellent thermal stability and transparency to UV light. It is used in high temperature environment as well as optical instruments. We have soda lime glass. This one is cheaper but less resistant to heat and chemical. It is used for disposable glassware and for microscopic or microscope slides. What are the tools and equipment that are used for glass blowing? So in order to shape glass or manipulate glass into their various shapes, the following tools are required. Number one, we have glass blowing lathe. We have lathe machine. We have the one that is used for metal. We have the one that is used for metal. I mean, for glass. So the one that is used for glass is what we call glass blowing lathe. It is used to hold and rotate glass tube for even heating. So we also have blow torch or Bunsen burner, which provide control heat to soften the glass. We have Allen oven. The function of Allen oven is to slowly cool the glass to remove internal stress. If you don't slowly cool it, if you cool it rapidly, then the glass can get broken as a result of internal stress. Then we have graphite paddle, which is used to shape hot glass. Then we have tweezer and forceps. It helps in gripping and pulling the glass into various shape. Glass blowing techniques. What are the techniques that are used? If you want to soften and shape glass now, you hit the glass tube with a blowtorch until it glows orange, until it turns orange. Then you now use the paddle that we talk about or the gravity to shape it. Then when you come to sealing and joining the tube, you melt the two glasses end to end. Then you press them together with airtight sealing. Then creating flares and bulbs. Blowing air into the softened glass to expand it into a bulb shape. You want to make a bulb shape of a glass. What you need to do is after the glass has been heated up, then you blow air into it to soften the glass. In order as it softens, then it will continue to expand until it reach the shape that you want. Then you now stop. Then hardening for stretching. We'll talk about this in the previous slide. It is used to slowly cool down the glass in an Allen oven to prevent crack. So application in biomedical laboratory. Glass blowing is crucial in biomedical lab for one, fabrication of laboratory equipment, customization of scientific apparatus, microfluidic, so that is small glass channel for blood analysis, then repairing broken glassware, thereby reducing cost and waste. In Nigeria now, we are talking about turning waste to wealth, recycling. So another way to recycle glass is through glass blowing. So while performing glass blowing, there are some safety precautions that must be put into place. Number one, when you are eating the glass, for instance, now, you need to protect yourself from it by wearing gloves and safety glasses. Then there should be proper ventilation. You must not inhale foam while eating up the glass. Then glass hardening, you don't just use bare hand to handle the glass, whether it is hot or you want to put it inside the oven to heat it up, or you want to use bottle burner to heat it up. So glass hardening, avoid rapid cooling to prevent crack. So you need to subject it to Allen oven. So that is that about improvisation and glass blowing. So the last aspect of this first lecture is construction of simple laboratory equipment. So we are going to be looking at 2 or 3 laboratory equipment, starting from a microscope. Construction of microscope. What is the preliminary information about microscope? So microscope consists of 2 lenses. We have the objective lens and the eyepiece. So the objective lens is a converging lens of a short focal length, which is typically around 40 millimeter and up to a few more. Then the eyepiece is also a converging lens with a focal length typically ranging between 50 and 15 mm. So the objective form a magnified upside down image. I know all this one is your work. I know you know them. So that is called intermediate image. So the eyepiece is positioned on the optical axis in such a way that its front focal length is on the intermediate image. So the eyepiece does function as a magnifying lens with which the eyes observe the intermediate image. So let's go to the construction. Now, if you want to construct a locally made, we talk about improvisation, you use locally available material to improvise some equipment. Let's look at how we can do that for microscope. These are the material that are required. Two lenses, as we have said, of focal length 35 mm, one for the eyepiece, the other one for the objective. Then two washer of diameter 17 mm, one black cardboard disc, diameter 17 mm, one plastic tube of length of about 165 mm, and internal diameter of 18 mm. Then we have one sheet of opaque glass paper dimension, that is to absorb the diffraction of a light inside the hollow tube. So we have one wooden of dimension 140 mm by 40 mm, by 140 mm by 10 mm. These are the material that is on my right hand side. So we still have other material, one strip of wood again with different dimension, 4 wood screw, length of about 20 mm, one sheet of pliable plaster to tape the black sheet together, then 2 balls of malleable plastic rubber. So these are the material that is needed to construct a locally made microscope. So how do we now go about it? You roll the sheet of black paper and insert it into the plastic tube. So the plastic tube can be the one that we use for our plumbing material, plumbing work at home. We call it PVC pipe. So you can just get a particular size that is suitable. Then you put a black paper inside it. You and put a lens on it. Apply ring around it. So then press the tube against the washer with the lens so as to join the part. To remove the excess plastic rubber. So the next one, then place the second lens. We have done for the first lens with the objective lens. Then you do the same thing for the eyepiece lens too. Then place the second lens on the second washer. So we repeat what we have done for the first lens, then repeat it again for the second. Then now this is the way it is assembled. The hollow plastic is mounted beside the wooden support. The wood just to provide the necessary support for the microscope. Now, the first microscope that we talk about has 2 lenses, the objective lens and the eyepiece. So we can also have microscope that has 3 lenses. We have the eyepiece, the field lens is the addition, then the objective lens. So I will leave all this one so that you can read them later. Remember, we will still do revision to concentrate on the area where you need to concentrate on. Then let's look at the construction of autoclave. We have talked more on autoclave in the second lecture note. So let's just look at the various components of autoclave. Number 1, the vessel pressure chamber. The vessel is made up of stainless steel. Stainless steel, that is where we put our material for autoclaving.
Recording in.
It is made of stainless steel. So the inner chamber is protected by outer jacket The inner chamber is the place where we keep the autoclavable material. I've already said that. So that is the function of the chamber, to accommodate the material. It is made up of what? So the lid of the door, the vessel mouth is covered by a lid, or at times we refer to this as a door. It is also made from stainless steel, the same material for the pressure chamber. So the lid allows trapping and retaining of heat and pressure inside the chamber and producing favorable environment for sterilization. So the lid is tightly closed with the help of airtight screw. If the lid is not tightly closed, there's no way we can achieve autoclaving because the steam will not develop. It will just be escaping. So pressure gauge now, what is the function of pressure gauge in an autoclave? It is present on the upper surface lid. That is for the bucket autoclave. Now we are talking about simple autoclave. Its function is to indicate the level of pressure that is produced during autoclaving. As you are autoclaving, you will see the pressure rising. What is get to certain pressure, let's say like 2 bar now, then is to maintain that 2 bar for the period of sterilization before it now starts falling gradually. Then release unit or whistle, just the same way we have it in our pressure pot at home. So the whistle is placed on top of the surface of the lid, just like pressure cooker. The whistle allows us to release the pressure whenever, to release the pressure to release the pressure. So the whistle allows us to release the pressure whenever it is required. That is when you want to dry. The pressure has to fall gradually. If the pressure did not fall, definitely you will not be able to open up the lid or the door. So the next component we want to talk about is safety valve. It is present on the surface of the lid. Their function is to avoid catastrophic accident, especially when the pressure inside the chamber is uncontrollable. You can manually press it so that the pressure inside the chamber can easily escape. Then the heater. The heater is the heating element that boils the water inside the boiler so that the water can be able to produce steam that is needed for the sterilization process. The last equipment is a laboratory incubator. So laboratory incubator is a heated insulated container that is used in laboratory to cultivate and preserve cell of microbial culture. Its main role is to control environmental factors like temperature, humidity, CO2, to create safe and reliable environment that is free of contaminants. As well as to teamwork. Let me leave this after you can read how it works later. Let's look at the component. We have cabinet, we have chamber for the autoclave, for the for the incubator now. We have cabinet. So the basic body of the incubator is the cabinet, which composed of a double wall cubical container with a volume ranging from 20 to 300 liters, depending on the sizes. So the outer wall is constructed out of stainless steel. Stainless steel has the capacity to withstand heat, and that is why any heating equipment you use stainless steel, and it can easily distribute through it. And inside wall is constructed of aluminum. The inside wall of the incubator has inward extension that hold up the cells. There are cells inside the incubator. These are the cells. So, and aluminum is so light so that it can easily take or accommodate the self. So the door now, we also have door. The door that seals the insulated cabinet is a standard feature on all incubator. So the door itself is what is also insulated. The essence of insulation is to prevent heat loss to the environment. We have control panel. The control panel consists of a switch, different kind of electronic devices, as well as thermostat. It is to control the temperature inside the incubator. We have what we call asbestos door gasket. The function of asbestos door gasket is to allow airtight barrier between the door and the cabinet. So we have door seal for that of autoclave. So the seal guide against damage of the cabinet. It keeps outside air from entering the cabinet, creating an enclosed hot atmosphere. It is not influenced. Hot atmosphere that is inside the incubator is not influenced by the environmental variable. So we have perforated seal. That is where we put our specimens, our culture, our media. So then the thermostat. The thermostat is to regulate the temperature. When the desired temperature is reached, then it turn off the control so that the specimen or the culture inside the oven will not be overheated. We also have L-shaped thermometer. The function of thermometer is just to indicate the temperature that is inside the oven. We have HEPA filter, high efficiency particulate filter. So some modern incubator come with HEPA filter. What is the function? Is to lessen the chance of contamination from air flow. So a closed loop system is created by an air pump with filter that lower the pollution in the air circulating inside the incubator. Air that circulates inside the incubator need to be filtered, and it is the function of the upper filter to do that. So we have humidity and gas controller. So a water reservoir is always placed beneath some incubator. And what is the function? What is the function? The water is evaporated in order to maintain the relative humidity inside the chamber. So similarly to that, gas chamber are incorporated into this incubator to give proper CO2 concentration that is needed for some experimental purposes. Okay, I think that is the end of the first class today. So we have talked about improvisation, glass blowing, and construction of simple laboratory equipment, the components that are used. We also talk about the materials that are used in constructing this equipment. Do we have any question before we move to the next slide, next lecture? Hello, sir. Hello, ma.
Oh, there's no questions, sir.
No questions, sir.
Thank you. Thank you. So, lastly, we want to quickly talk about design techniques, improvement on existing equipment, review and modification of laboratory method. That is what we want to look at in the next 30 minutes. So, design techniques in biomedical engineering. When you see BME, I mean biomedical engineering. So design play a vital role in biomedical engineering as it directly influences the safety, effectiveness, and usability of medical devices and equipment. So with the constant advancement in medical science and technology, there's a growing need for continuous improvement and redesign of existing devices to meet emerging healthcare demand. So engineers, biomedical engineers, we are not left behind in this. So engineer must be adept to apply design techniques to solve problems, reduce costs, improve outcome, and also enhance user experience. So what are the design techniques that we use? What are the processes? When you want to design in biomedical engineering, you don't just wake up one day and say you want to design. It involves processes. So the processes include number one, problem identification. If there is no problem, then there cannot be a solution. We need to identify the problem that you want to solve, then have a deep understanding of the clinical need and the shortcoming in the existing technology. Maybe a particular medical device does not have, let's say power backup, for instance now. When there is power failure, the equipment just shut down, and you want to design something and embed it in that equipment so that whenever there is power failure, at least it can work for maybe like 30 minutes or an hour before generator or power is restored. So you need to understand the problem first. Number two, the concept development. After problem identification, then you need to come up with a concept. And this cannot be done all alone. We need to brainstorm and evaluate possible solutions. At times, there could be 3, 4, 5 solutions to a particular problem. So when you brainstorm, be able to identify, okay, maybe this solution will be the best for this problem. Then prototyping. After concept development, then you go to what you call prototyping, which is creating a preliminary model to test the concept that you have already developed. After prototyping, now test and validation. That is assessing performance and put into consideration safety and compliance with standard as well as regulatory requirement. After all those has been done, then you can now go to mass production and deployment, which is the final stage of the design. Design techniques. We have talked about the processes that involve in the design. What are the techniques that are used in modern biomedical equipment these days when they are doing their design? Number one, system engineering approach. What is system engineering approach? It is an interdisciplinary method that focuses on defining customer need. What is the customer need? Customer need might be different from what you think you want to do. And you are not the one that will use the equipment. You are not the one that want to use the solution. It is the customer. So it is what the customer need that you need to develop. So, and system functionality early in the development cycle. So you need to identify the customer need and the system functionality. What are they using presently? Why you see that what they are using presently is not meeting their need. So you need to identify that under system engineering approach. Then the next one is computer-aided design. This day, we use CAD in designing. Different CAD software is available this day. So CAD is used for drafting and modeling parts and system in 3 dimension, 3D. So CAD helps a lot these days when it comes to design. Then another method that is used in modern biomedical equipment design is what we call finite element analysis, which involves assessing how the design will react to real world, such as pressure or stress. So software are also used for this, something that a console, MATLAB can be used for this. It's like simulation. Want to see how it will look like in the real life using computer system or computer programming. So prototyping now, which involves 3D printing, you now print whatever that you have simulated, you print it. Another technology to quickly produce physical model. You used whatever you have printed to do what? To now make a physical model which can now be deployed into the market. And while doing that, ergonomics and human factor will also be put into consideration. So the design is aligned with human capability and limitation to minimize error and improve usability. Improving existing equipment. Now, we want to improve existing equipment. Why do we want to improve it? So techniques for improving existing equipment in biomedical equipment often involve iterative testing and integrating of feedback. We want to test what is already on ground. We want to ask questions from people. Why do they need more improved equipment? So there are key techniques in carrying out all this. Number one, you need to carry out what we call root cause analysis, RCA. Identify the fundamental problem causing inefficiency or failure of that equipment. Then user feedback and clinical trial. You ask questions from those people using it, you ask from the patient, then you carry out what we call clinical trial. Thereby, you gather insight from the real user, which will guide you in doing your updates. Then retrofitting. Retrofitting means adding modern technology such as sensor or IoT. IoT means Internet of a Thing capability to other equipment. As a biomedical engineer, I should be able to sit in my office, look at my system, and monitor my equipment in theater. Is it functional? Why is it not functional? This can be done by integrating a sensor or Internet of a Thing that will monitor the real life situation of the equipment. Then material substitution, using more durable, compatible, or cost-effective materials. At times, what we need to use is just to change the materials that we are using. Most of the equipment that they give us in West Africa or in Africa country is not actually meant for us. The material that they use there can withstand we only survive under a certain temperature. But in our area now, there's no AC, there's no that. So most of these equipment, they break down easily. So if we can get material that will be adaptable to our own environment, then it can serve as a means of improving the existing equipment. Then energy efficiency and miniaturization, which is design devices that consume less power and occupy less space without compromising performance. Now, when we want to improve on existing equipment, so in biomedical engineering, there's what we call reverse engineering practice. Reverse engineering is the process of redesigning an existing equipment to improve or broaden its functions. It is working or it might not be working, but you want to add some feature to it so that its function can be what? Can be broadened, and also add quality and increase its useful life. So the main aim of reverse engineering is to reduce manufacturing cost of new products, thereby making it competitive in the market. So the duplication is done without the aid of drawing, documentation, or computer model. What I mean by this is that most of the equipment I want to do reverse engineering for, you don't have access to their drawings again. You don't have access to their document. You know manual, nothing. So you just want to use the existing equipment that is available. You want to perform reverse engineering on it so that you can make it to be more functional and add some quality to it. So why reverse engineering? Why did we come across reverse engineering? Number one reason is that the original producer no longer produces the product. In my own facility, there are times we just may, in fact, recently we encountered this kind of problem. You will make the manufacturer that you need some certain things. They will tell you that we have moved on, no, we don't produce such again. We are now in another fashion. So there's no way we can get that part for you. So if that happens, then reverse engineering is another thing that can be adopted. So there is inadequate documentation of the product. When the equipment was purchased, for instance, the contractor, the supplier, they will hide the technical manual. They will not want the engineer to see it. They will not, so if there is no proper documentation and you want to work on equipment, you want to add some feature to it, then you have to do it your own way. Then perform what you call reverse engineering. So but some bad features of the product need to be redesigned to update obsolete materials or antiquated manufacturing process with more current, less expensive technology. These are the reasons that led to reverse engineering. So what are the methodology used in reverse engineering? So let me talk about that using this picture of an iron. This is an electric iron. This is the physical product. I just use this as an example. I can use any medical equipment. The same process also apply. I can use a centrifuge. I can use Elisha water, Elita reader. Just the same process. Now, this is the physical product, an electric iron. Now, I want to perform reverse engineering on this now. So I don't have the drawing. I don't have any manual. What do I do first? The first thing for me to do is to obtain the dimension details. How do I do that? I can do that using two methods. Manual measurement, maybe I take my ruler, begin to measure, or I can use optical measurement by use of light or laser. So after that, I perform what is called 3D model. After the 3D model, I will inspect the model with the physical model. That's why we are having two here. So after that, then you create manufacturing drawing. The drawing that was not available before, now create as a result of the data that you have already gathered in these three previous stages. So after you have created the manufacturing drawing, then you continue with process for manufacturing. So this is just a brief analysis of reverse engineering. Now let's now take it one by one. We talk about obtaining dimension detail. You can do that using what we call digitizing. That is collecting data from physical parts. You used when drawing of object is not available, which I've already mentioned. The aim is to generate 3D mapping.
Right. I can't see the video of the slide that the lecturer is taking. I don't know what happened. No, I'm seeing Don speaking, your microphone unmuted, video is stopped. I'm hearing the voice of this lecturer, but I can't see the slides.
The slide is on. You are
okay.
It is your network.
The slide is on, so you are just
probably your network or your system, ma.
So they said that the slide is on, so please kindly work on your device.
You can log out and re-log in.
So after you might have gotten the 3D mapping, so this require acquisition of surface data, which is a large number of points. So how do you acquire this data that is needed for the 3D mapping? So there are two methods which I talked about before, manual and the use of light. So, but we can also, okay. So for these two types of processes, we can use what we call contact or non-contact. The contact is the manual. So the contact method requires contact between the component surface and a measuring tool. So you can use what we call coordinate measuring machine, CMM, or electromagnetic digitizer or sonic digitizer. All these are contact method, or we call it manual method. Then the non-contact method, it uses light as the main tools. It uses white light or laser scanner to scan the 3D object in order to generate the card design. All this is as a result, we want to get data, we want to get the measurement of that device. Now, the data that you have gotten, how will you now manipulate it? So basically, after completion of the three of this card model of a product, after it has been obtained, then use it to fit geometric to the large number of points. So it is possible to have a larger number of points on a particular equipment. So how do you now manipulate it? So the surface can be mathematically defined as algebraic or parametric surface. So the surface fixing technique can be of two types. How do I manipulate it? So I can use two types. I can use interpolation method or approximation method. So in interpolation method, the surface to be fitted passes through all the data points. If you have like 10 data points, you pass through it, you take measurement through it, then use when the data points are accurately measured without error. In order for use interpolation method, then you need to do accurate measurement of those points. So approximation method now, it is used when you have a larger number of data points. So if you have like 1,000, or let's even say 100 points, measure it one by one, then integrate it together might not be easy. Might not be easy. Then we use approximation method. It is used when large number of data points are to be fitted. So generation of functional parts. So after all this data, how will you now generate functional part? The geometric method obtained can be used as the basis for a variety of operations. Operations such as automated process planning, automated manufacturing, automated dimension inspection, and automated tolerance. So those are the things that we can use all this our manipulation to do at the end of the day. What are the advantages of reverse engineering? So reverse engineering typically starts with measuring an existing object so that a solid model can be deduced in order to make use of the advantage of CAD, CAM, CAI, and the rest. All these just are CAD different software. So CAD models are used for manufacturing or rapid prototyping application. Hence, we can work on a product without having prior knowledge of the technology that was used initially in manufacturing such a product. So advantage now, number one, it is cost saving for developing new product, lesser maintenance costs, quality improvement. You can add quality to the existing equipment as a result of reverse engineering. Then you have competitive advantage in terms of the costing. It will compete with the new products in the market. So the last aspect, review and modification of laboratory methods. Biomedical laboratory, or let me just say medical laboratory, rely on standardized procedure to ensure the reliability and validity of experimental and diagnostic results. However, continuous advancement in technology, clinical needs, and regulatory requirements necessitate periodic review. We need to be reviewing our method, the method that we are using. We need to continue to review it in order to know whatever we are doing, is it accurate or not? So a modified laboratory method is a critical quality assurance. So in quality assurance, we need to do what? We need to continue to review our laboratory method in order to enhance performance, reduce error, and maintain compliance with international standards and with regulatory requirements. What are the key terminologies that are used in review, in laboratory review? Number one, laboratory method. Laboratory methods is just a documented and a standard procedure. We call it SOP at times, the standard operating procedure. I want to do a PCV, for instance. Now maybe I take something from somewhere, I take my card, I move to another place. No, those are the procedures. So documented and standardized procedure used in analysis, diagnosing, or research involving biological samples. Method review is a systematic evaluation of an existing laboratory method to assess its accuracy, reliability, and suitability. If it is not accurate, then we perform modification. Method modification is the art of changing a laboratory method based on the evidence from the review that we have done, with the goal of improving outcome or adapting to new needs. So those are the three terminology that are involved when we talk about laboratory review and modification. What are the reasons for reviewing laboratory method? Number one, advancement in technology. Newer or more accurate tools may replace outdated systems. So if you have newer technology that take lesser time, then we might need to review our laboratory method. So the time that we spend to diagnose a particular sample now may have been reduced. If it is reduced, then you don't need to have a cumbersome processes. You need to review it, then adjust accordingly. Regulatory compliance. Compliance with standards such as ISO 15189 and CSR guidelines may require method re-evaluation. This international organization, they may require us to carry out some kind of review in order to be able to be certified. So performance issue. Inconsistent or erroneous results may also indicate the need for review. Somebody that does not have hepatitis B now, he went to a particular lab, they say he's positive, go to another one, that one says it's negative, go to another one, the other one says it's negative. Then the first one that says it's positive need to review the laboratory process. Then feedback from user. Laboratory staff or clinician may report difficulties or inefficiency. So if there are difficulties, if there are inefficiency, if there are bottlenecks as a result of feedback from user, then we might need to review. In my own facility, sometimes ago, they say there are a lot of queues, queues at the universal laboratory. Queue, you see just patient relative on queue outside. So, and they review it. They have to go somewhere from there before they can now call them one by one to collect their result. And there is an improvement. There is a positive feedback as against what it used to be. So changing clinical guideline, for instance, now, evolving medical protocol can influence diagnostic criteria and require lab output. Now, we are talking of electronically sending results. All those kind of things need review before you can now adopt it. So, steps in reviewing laboratory method. Now, we have ascertained that we need to review this method. What are the steps that we need to take? Number one, document review. Examine the current standard operating procedure. You need to examine it, what is wrong with it. Then performance analysis. Evaluate accuracy, precision, sensitivity, and specificity using historical data. You compare previous data, maybe data of January, compare it with that of June. Data of last year, you compare with that of this year. Is there any variation? That is performance analysis. Then comparison with benchmark. What is the benchmark? What is the benchmark saying? What are we getting? So from there, we'll be able to. Then consultation, which involve lab technician, pathology, clinician, biomedical engineer coming together to perform the review, then risk analysis, identify any hazard or safety concern that is associated with the method that you want to adopt. You want to adopt another method. Have you analyzed the risk? Is there any hazard that is associated with it? So all these need to be looked into. Now, how do we perform modification now? It has been ascertained that there is need, we have reviewed and we need to modify it. We need to modify our existing laboratory method. How do we now go about it? So modifications are made after successful review, identify area of improvement. So there are types of modification, and this include changing reagent. Changing reagent, as simple as it may sound, it may be the solution to the review that we have done. So for instance, now using more stable or cost-effective chemical can be the game changer that we make our laboratory review to be modified accordingly. Then altering protocol step, there are different kinds of bureaucracy that are involved. So we can cut some of them. So improving efficiency or clarity of workflow. So let Mr. A know what he's supposed to do. Let Mr. B know what he's supposed to do. There should not be class of interest when it comes to protocol of individual. So adopting new equipment, integrating automation or digital readouts can also be a solution to the review that we have done. Instead of patient coming for their result, we can even send it to them, send it to the clinician electronically without them even coming. So miniaturization, which is reducing sample or reagent volume in order to conserve resources. So environmental adaptation, modifying method to suit feed or low resource setting. All these are the methods that we can use after we have reviewed our laboratory processes and want to perform modification. These are the methods that we can use to modify it. What are the tools and techniques for review and modification? We have statistical tools, or we call it statistical quality control tools, such as control charts, blunt ATMA plots, that is a graph, t-test for comparison. T-test is a statistical tool that compare more than two variables together. Compared to them, you now look at the one that is deviating from the mean. Then simulation software like MATLAB, LAVIE for modeling workflow or process changes. Change control system, documentation tracking is another tool, approve log and version control. Then lastly, feedback system. We can just perform anonymous survey. You don't need to ask the name of the person that did the survey. Just go and do this for me. Don't ask the respondent. Don't ask them their name. Just ask this question. So post modification audit. So after all this has been done, then we now need to audit it so that we know which one to remove, which one to adopt. So on that note, we come to the end of MLS 404, Biomedical Engineering. These are the case study of review of laboratory process and modification that are done. So we can read all the case study 1, case study 2, and case study 3. So do we have any question before we quickly look at what do you call it? So we want to look at.
The lecture is well understood, sir. Thank you
All
very
right.
much.
Thank you so much, Ma.
Thank you
So,
very much, sir.
Thank
all
you, sir.
right. Yes, Ma, you are
So,
welcome, sir. You are welcome,
no
Ma.
question, Abi?
No, okay, do we have
Do
questions?
you have any question?
No question.
Okay.
So let's quickly review. We are doing MLS 404 review now, just to look at what we have done so far that can aid
Hello,
us.
sir.
Yes, ma.
I'm sorry, I want to ask a question.
Okay.
Like, there's a friend of mine that her
Yes, ma.
daughter is a biomedical engineer.
Okay,
And
ma.
when the daughter wants to do internship, so
Yes.
she informed me that I should please help her get where the daughter can do the internship. But me, I don't know the place that she can go. I thought if she come to our own hospital here, there's nothing she can do here. So where are the places that as a biomedical engineer that
Where
they
is
can work?
where is the person located?
In your town,
Or your town?
or she's
Okay.
schooled in Ibadan. Yes, sir.
Okay. And the person is not ready to move to maybe Ibadan, Lagos, or any capital
She's
state.
ready. She's ready, sir. She's ready.
Okay. Well, we have different aspects of biomedical engineering. And the one that we are practicing and that is so common now is the clinical engineering aspect of it. And those are the engineers that biomedical engineers that work in the hospital. So it is not only the hospital that the person can work as a biomedical engineer. We have some people that are
Taking gate
biomechanists.
wọlé. Okay.
Yes, sir.
We have some people that focuses on biomechanics, and that has to do with the movement of human body. We have some people that are focusing on biomaterial engineering. Those people that can work in the lab where they perform tests on different kind of biomaterials. So such an individual can work in NAFDAC. Such an individual can work in Standard Organization of Nigeria. Such an individual can work in research setting aside from hospitals. The hospital take a larger number. In my own hospital, for instance, now we employed 10 biomedical engineers this year. So massive. I was not even expecting that they will be up to that. So we employed 10 biomedical engineers. So ma, if the person is ready to move outside Oyo, he or she will be
Yes,
able
sir.
to get placement. So you can
Okay, sir.
collect my number from the class rep.
Can I send that to you, sir?
Collect my number from the class rep so that we can talk later.
Thank you very much, sir. I'm very
All right.
grateful, sir. God bless you, sir.
Oh,
You can
thank
apply
you.
to NCDC too. NCDC.
What's the full meaning of that?
NCDC, Nigeria Center for Disease Control.
Yes, sir. Yes. In fact, some of our guys even resign and join them. So some of our guys resign. Then Laboratory Council of Nigeria, your own professional body, they also
Yes.
take biomedical engineer.
Naima.
Okay, sir.
A colleague of mine resigned from UCH and joined them, and they pay well too. So
yes.
Okay.
All right.
Thank
So
you very much, sir.
all right, you're welcome, ma. Let's quickly look at what we have done so far so that this one will help us in preparing for the exam. So our first lecture, we talk about workshop practice. But I started the lecture by giving us introduction to biomedical engineering. But for the purpose, let me say that you should be expecting 6 questions, and you are going to answer 4 out of that 6. So each of the slides will carry one question. So I can decide to maybe mix 2 lectures together. So if I see there are too much calculation in a particular question, I can take the calculation to another question and bring question from another question to join that one so that everything will be balanced. Because I know that some people may be running away from calculation. So for the first slide, you should know what is called workplace or workshop place. So you should be able to understand the component of workplace. You should not be able to understand the component of workplace. We also talk about hazard. So this is workplace, or you call it workshop place. So component of workshop place, we talk about the physical environment, operating environment, then and the likes. Then we talk about hazard. We also take note of that. We talk about safety. So then we talk about the safety precautions that we might need to take note when we are working in laboratories, even in our medical laboratory. What are the precautions that we need to put in place? Then you should also seriously take note of troubleshooting procedures in biomedical engineering. When you want to troubleshoot an equipment, I think this particular slide. So what are the techniques, or what are you to do? Troubleshooting procedures, visual inspection, use of sense of smell, all the likes. You need to take note of them. So I don't think that is the end of the first lecture. So you should be able to take notes of one or two things that I've mentioned. So the second class, or the second note, we talk about principle of use, maintenance, and repair of common laboratory equipment. So we start with a microplate reader, which is also referred to ELISA techniques. So you must know, or let me say, read the principle of operation of a microplate reader, ELISA washer, and centrifuge. Their principle of operation. Their principle of operation. Take notes of that. Then, towards the end of this slide, we talk about autoclave. We talk about oven, and I made mention of the differences between the two. Also take note of that. So I can assure you that you should not be expecting calculation on centrifuge. I gave you I will call it classwork, because some people submitted it as assignment. I just want you to practice it. So, but I will not bring any calculation on centrifuge. I hope that is taken. So, but all those equipment that I've mentioned, go and read their principle of operation and know the difference between an autoclave and oven. So I think that is that for the second lecture note. Let's move to the third lecture note. So in the third lecture note, you need to know the calculation under resistor. Resistor in series, resistor in parallel, and also capacitor. Okay. And also capacitor in series, capacitor in parallel. You should know that. Then you know electric current, electric power, and electric energy. Electric current, electric power, and electric energy. Know their calculation. And when we were having this class, somebody asked a question on the flow of current and flow of electron. So you should also take note of that. So also take note of that. So all these calculations, they are not difficult, but take note of it. Flow of current, flow of electrons. So take note of that. And calculation under power. calculation other power, calculation other electric energy. You also read it. So listen, if you are giving,
People should move themselves. This session is very.
if you are giving a question, for instance, now that an autoclave has 3 elements of 1 kilowatt each. If I now ask you, calculate the total power, it is very simple. I said it has 3 elements, each of them 1 kilowatt. Just 1 plus 1 plus 1, that is 3 kilowatt. So if I ask you to go further by calculating the current now, of course, I will have given you the voltage, and you know the formula of power, P is equals to IV. So you should be able to do such calculation. Then energy, we know that energy is equals to power times time. So know how to manipulate all those things and get your calculation right. So I think that is all about this second slide, third slide. So you don't need to bother yourself about resistor color coding. Where is it? Okay, that I've already passed that one. So you don't need to bother yourself about that. Don't bother yourself about semiconductor as well. So let's move to the fourth lecture. So in the fourth lecture, we talk about circuit diagram. We talk about block diagram and computer programming. So for this aspect, we know what is block diagram, know how to draw block diagram, and know how to explain each of the block. So you don't have much block diagram. This is for audio amplifier, this is for radio receiver, this is for regulated power supply. Know how to draw block diagram and explain each of the circuits. So circuit symbols. Of course, you will need circuit symbol to draw circuit diagram. So you need to know most of these circuits symbol so that you'll be able to draw circuit diagram. So we said that circuit diagram show how electronic components are connected. So if you are giving, look at it now, this is a cell. So if I say that draw a circuit diagram of a 12-volt battery that consists of 3 cells, that is to tell you that you will join 3 of these cells together. And the circuit has a switch. That means you connect it to a switch, and the circuit has a resistor, and the circuit has a LED is what we call light emitting diode. So you will be able to draw the circuit diagram based on what is given unto you. So are we following, please?
We are following.
Yes, sir.
So you should be able to draw the circuit diagram based on the information that is given unto you. I think that is all about that. Now, in the computer programming, so just focus on page 1 and page 2. Page 1 and page 2 of your notes. That note that I gave to you, page 1 and page 2, read it very well. Then after you might have read page 1 and page 2, then you now go to basic programming. Basic programming. That basic programming, I'm not asking you to write a program, but know how to use user-defined words in basic programming in basic program syntax to write formula. If I give you formula like say the area of a rectangle is equals to length times breadth. Write it write it in basic program language syntax. You should be able to read that. You should be able to do that. It's inside your note. So focus on page 1 and page 2. Then you now move to you now move to basic programming and focus on the syntax. Focus on the syntax, how to write formula in basic language programming syntax. I've given you an example. Area of a rectangle is equal to length and breadth. Write it in basic program language syntax. So that is all for computer programming. So the one that we did today now, so all this one are still fresh. So we started with improvisation. So what is improvisation in biomedical engineering? So why is it important? Why is improvisation important? So what are the skills that are involved? And what are the guidelines for effective improvisation? So you need to take note of that. Then what is glass blowing too? We'll talk about glass. What is it? What is glass blowing? What are the various type of glasses that are used in glass blowing techniques? And they are, when you talk about them, then you need to talk about the characteristics of those glass too. You cannot just say borosilicate glass and just keep quiet. Why are we using borosilicate glass? It has high efficiency, high resistance, all those kind of things. So you need to put that into consideration why, if any question of such nature comes out. Then what are the tools and equipment that are used in glass blowing? We mentioned lathe, we mentioned blowtorch or Bunsen burner, Allen oven, and the likes. So we need to look at that. Then you need to look at some components of autoclave and laboratory oven. They are components. So when you talk about components, don't just mention, for instance, now this one, don't just say cabinet and keep quiet. What is the cabinet? To be able to write one or two things. The door, what material is it made of? The control panel, the asbestos door gasket, all those kind of things. So you need to take note of that. I think that's all for the 5th lecture note. Then lastly, the 6th lecture note. So we talk about design techniques that are employed in biomedical engineering. This place, we talk about design techniques. But before we get to that place, we talk about processes that are involved, problem identification, concept. Then after you might have done all those, what are the design techniques that are used into this modern biomedical equipment? So you need to know that. Then reverse engineering. What is reverse engineering? Why do we decided to adopt reverse engineering in biomedical engineering practice? So you need to do that. So, but if I now give you equipment that water bath, for instance, now that use the process of reverse engineering to do what? To manufacture an obsolete water bath. So just use this process and explain. So I think that is all about reverse engineering and design technique. Then review of laboratory procedures. So what are the key terminologies that are employed in laboratory method and method modification? So there are three numbers. So we have mentioned that. What are the various stages that are involved in reviewing laboratory method. What are the various stages? What are the various stages? Or what are the various reasons? What is the reason why I want to review? Reason why I want to review. And what are the steps that I need to take while reviewing? So we need to take note of that. So what are the modification methods that we can employ? Different, can be as simple as changing reagents. It can be altering protocol. So all these ones, they are simple and straightforward. Then what are the tools and techniques that are employed for review and modification? We talk about statistical quality control. So if something like this comes out, don't just say statistical quality control and keep quiet. You need to mention the statistics and tools that are used under it, control chart, Blanchard. When you talk about simulation software, don't just keep quiet. Simulation software, mention the example, MATLAB, LabVIEW for modeling workflow and the like. So I think with that, I wish you best of luck, and I wish you success in your forthcoming examination. Do we have any question before we call it a day?
Amen, sir. Thank you.
Amen, sir.
Yes.
Hello,
So,
sir.
yes, ma'am.
Hello, sir. Yeah, please, you didn't have a complete note on programming.
I gave all the note that I saw you now. I gave
On
it to the
programming,
class.
it is not there, sir. The one you gave us now is not on the one you sent to the class.
Okay.
Programming is blank.
The programming.
I gave a note, a separate note, not a slide. A separate note, not a slide on programming. I sent it to the class rep. Class rep, are you there, sir?
Not with us yet, sir.
Not with us, sir.
That ones with the programming.
Are you saying this one is not with you?
Yes, sir.
Class rep, can you confirm that, sir?
Hello, sir.
Yes, sir.
I didn't hear what the last speaker said.
Can you confirm if you have this note, computer programming or not?
No, I don't.
You don't have it?
Yes, sir.
Let me check
Every slide I have, I've shared with them.
This particular one is not a slide, though. It is a note.
I don't have the note, sir.
My brother, you have it.
Sir.
You have it.
Yet.
I said it. Hold on, sir. I sent it to you on the 20th of June. I sent it with the 4th lecture note. I sent it together. I'm seeing it now. So go to your phone now, sir. Go to our chat.
I will go and check it, sir.
Check it now before I log out.
Okay.
Thank you, sir.
It's there. I sent it together with the 4th lecture note.
There's so much notes, lectures.
Just check my own chat, our chat together. You will see there. Go to the 20th of June. 20th of June.
Can you kindly share your,
okay, sir. Yes, I'm in transit. Sorry, I'm in transit. I've been doing everything on transit.
Okay, no problem. Just go to the 20th of June.
Okay, on the 20th, sir, you said.
Yeah, 20th of June. Computer edited.
Okay, maybe that's why I didn't. Okay, I've seen it. It came separately.
Yes, it is separate from the
So I was looking at the PowerPoint.
No, there's no way I can put this one on PowerPoint. That's why I said it now. Okay.
I'm sending it to the group so everybody can go and check it.
Okay, so as I've said earlier on, just reach page 1 and page 2 of this. Then you now go to the to the basic programming language and understand the syntax to use it to write a formula. So any other questions that Amma?
It has been shared.
All right. Thank you. So, in the absence of any other question, once again, I wish you best of luck. And we'll see some other time.
I have a question.
All right, what question do you have?
Thank you, sir.
Yeah, in the course of the lecture, listening to this lecture,
Engineer,
you mentioned one
please,
abbreviation,
Temper
IoT.
Justice is messy. Oh.
What's the meaning of IoT?
I can't hear you.
I said you should please temper justice with mercy when you are marking us.
Don't worry now. It's only certificate that you need now. You can't fail.
I
Yes.
have first class.
Thank you.
Thank you, sir.
You can't fail.
Thank you, sir.
I'm you.
Uh-huh.
Yes, sir.
All right. Oh.
Thank you so much, sir.
All right. Good night.
Good night, sir.
Good night, sir.
Thank you, sir.
God bless
God bless
you.
you.
Good night, sir. So I will share this the recording because in the middle of the recording, our recording capacity was filled up on Zoom. So I will share the YouTube recording so we can go over it via the YouTube. We should just pay attention to the last part of the lecture where he talked about what we should read. So I'll share it the moment we all leave the class. So once I end this lecture, this class, I will share it. All right.
So I want to suggest that those that maybe jot something down during the revision
Anybody that missed
period.
it, we will go and listen to it via the YouTube recording now.
All right, all right.
So at least that you can play it over and over and over and again. You can download it. You can do whatever you like with the YouTube recording.
All right, sir. Thank you very much, sir.
All right, man. So I've shared the last notice the lecturer sent, so we can go and read.
Hello, kàwé Ọlọ́run kó ṣe ń rọrùn.
Hello, kàwé exam ti kanlẹ̀kùn.
Kọ́lọ́run ṣàánú wa wá tààrà ọjà kọ́lọ́run bá wa.
Ẹ̀ka náà ni o, wọ́n ti fún yín ní area àtẹ̀má consent. Let's just find a way of looking at how we can, manipulate
right.
what you said.
Allah help us. Ọlọ́run ràn wá lọ́wọ́.
Amen. So, good night, everybody. I've been in transit all morning, so just getting on.
Okay. Ẹ máa rest o.
Mi ti wọlé gan, mo ṣe wọlé street. Gbogbo time tó ń sọ yẹn.
Ẹ máa rest o.
Mo ti ń feel dizzy gan, mo ní láti. So mo ti set kí n take it easy.
Ẹ̀rọ máa ṣe o, ẹ jọ̀ọ́ o.
I've been engaged in kí n máa pè ní administrative work at the secretariat with director.
Ẹ lọ gba PA, ẹ lọ gba PA.
No, it's the director that is using me to do, and I don't have a choice.
Okay.
All right.
Níṣẹ́ lásán lágbára náà. Ẹ bá mi kí gbogbo ilé o.
Yes. So, good night, everyone.